Hello all, welcome to the course on Python programming for beginners. We are in Module 3, Python data types, Lecture 1. In this lecture, we will be discussing about Python variables, assigning values to variables, rules for naming Python variables, Python constants and literals. Let us begin this lecture. A variable in Python is the label given to a value or an object. It also represents the storage area to hold the data. For example, let us see the variable x that is assigned with the value 20. In this statement, x is used as a label for the value 20. And similarly, y equal to 30. Here, y is the label that is used for storing the value 30. If we print the value of x and y, the output will be x is 20 because x is the label given to the value 20, and similarly y is the label given to the value 30. Let us check another piece of code where we are assigning the values of 20 and 30 to the variables x and y, and we are also printing the id of x. So here id is the unique identifier of any variable or object which we are passing as an argument. In this case, for the id function, we are passing the argument x. That means this statement is going to print the identifier of the variable x, which is nothing but the memory location where the value of x is being stored. Since x and y are storing different values, which are 20 and 30, the memory locations, if we observe, they are different. Let us also observe another piece of code where the values of x and y both are assigned with 20. That means both the values of x and y are same. In this case, if we try to print the id of x and id of y, both are same. Though we have given two different labels for the same value 20, the memory is going to be allocated only once. That means the same memory location is labeled with two names which are x and y. This is how the memory is being allocated for the variables in Python. That means if the same value is assigned to another variable, then a separate memory location will not be allocated. Instead, the same memory location will be used by the second variable also. So we have used the id function in the previous print statement, and the id function returns the unique identifier which represents the memory address of the object. Here you can see the diagrammatic representation of whatever is being discussed in the previous slide. When the variable values x and y are different, that is 20 and 30, two different memory locations are allocated, each for x and y. That is, the value 20 is labeled with x. The memory location where 20 is being stored is labeled as x, and the memory location where 30 is being stored is labeled as y. That is why there are two different memory locations. If you look at the next diagram, here both the values of x and y are assigned with the same value, that is 20. That means here there is only one memory location that is shared by both x and y. That is why the output is giving the same memory location. Python variables need not be defined explicitly. if you are familiar with any other programming language like C or C++, there we have to declare the variables before using those variables. Whereas in Python, there is no such explicit declaration required. Let us observe this piece of code. Here, the variable student underscore name is assigned with the value, which is a string, that is Aditya. And then the age is another variable which is assigned with the value 20. Similarly, another variable gender, that is assigned with the value M, which is a character type. And similarly, CGPA is another variable which is assigned with a floating point value. And C1 is another variable which is assigned with a complex number. So in all these cases, in all these different variables, you can observe that all these are holding different type of data. Student name is holding a string, age is holding as an integer value, and gender is holding a character, and CGPA is holding a floating point data, and C1 is holding a complex data. Though we are assigning different types of data to the variables, we are not explicitly defining the type of the variables. And then we are printing the type of each of these variables by using the type function. So type of student name gives you the type of the data that is being stored in student underscore name. Similarly, type of age gives the type of the age, and similarly type of gender and type of CGPA and type of C1. So if you look at the output, student name is a string class, age is an int class. So you can observe that all these data types basically belong to a class, and the variables that are declared with the specific data type belongs to the specific class. For example, student name, student underscore name is an object of string class. Similarly, age is an object of int class. Gender is an object of str class again. Here there is no distinction between, in Python there is no distinction between a character and a string. Character is also a string with a length of 1. CGPA is an object of class float, and C1 is a complex class. And here we have used the type function that returns the class type of the argument passed as a parameter. Now let us see how to assign the values to Python variables. The assignment operator equal to is used to assign the value to a variable. When we assign any value to the variable, only then the variable is declared automatically. That means we need not define it explicitly. Instead, whenever we assign a value to any variable, only then the variable is declared automatically. There is no explicit declaration required. And there are different ways of assigning values to the variables. You can assign a single value to a single variable by using simple equal to assignment statement, x equal to 30, and you can also assign single value to multiple variables. That means you can assign 50 to the 3 variables a, b, and c in one single statement by using multiple assignment statement. A equal to b equal to c equal to 50. That means all these 3 variables are assigned with the value 50. And you can also assign multiple values to multiple variables by using one statement by using p, q, r equal to 10, 20, 30. Here the values are assigned to the variables in the order of in the order in which they have been declared in the assignment statement. That means p is assigned with the value 10, q is assigned with the value 20, and r is assigned with the value 30. If we try to print the values of all these variables, assigning a single value to a single variable, print x equal to x. Here the value of x is printed as 30. You can observe in the output here. And similarly, a equal to b equal to c equal to 50. After this assignment statement, if you try to print the values of a, b and c, we are going to see that the output is printing a equal to 50, b equal to 50 and c equal to 50. So instead of using 3 assignment statements, we are able to assign one single value to all the 3 variables using one assignment statement. Similarly, the third assignment statement where the values of P, Q and R are assigned with the values 10, 20 and 30. Now let us see the rules for naming the Python variables. A variable name must start with a letter or an underscore character. And the second rule is a variable name can only contain alphanumeric characters and underscore. That means the variable should not contain any other special characters other than the alphabets, numbers and underscore. Variable names are case sensitive. That means the variable age is different from age with the capital A and similarly age with all 3 capital letters. A variable name should not be any of the Python keywords. Python program has certain keywords and whatever the variable name that is used by the program should not be one of these Python keywords. So these are the naming rules. Whenever we write the programs, we have to keep these rules in mind before declaring or using any variables. Now let us see some techniques to make multi-word variables more readable. Sometimes not just single word, we may be interested in using multiple words for the variables. So in such a case, for example, if you take student name, if you write without any distinction between these 2 words, then it will be not readable. That means the readability won't be there for the variable names. So in such a case, there are certain techniques that are used whenever we use multi-word variables. That means either we can go for a camel case naming convention or Pascal case naming convention or a snake case naming convention. In case of camel case naming convention, each word except the first word starts with a capital letter. So here in case of student name, it consists of 2 words. The first word will be normal, that is the lowercase, whereas the second word starts with a capital letter. Similarly, in the Pascal case, all the words in the variable name begin with a capital letter. In the snake case, each word is separated by an underscore character. Since there are 2 words, student and name, both are separated by using underscore because underscore is a valid character in the variable name. Now let us look at the Python constants. Constant is also a special type of variable where the value cannot be changed throughout the execution of the program. That means for any other variable, if you write x equal to 10, you can modify it as x equal to 20 at a later part of the program. Whereas for a constant, once you define the value for a constant, you are not allowed to change throughout the execution of the program. Though there is no direct provision of constants in Python, you can still use some naming convention by declaring them as capital letters in the variable name. So in order to indicate that it is a constant, and care has to be taken not to modify that value throughout the execution of the program. For example, here you can define a constant pi equal to 3.14 And of course, r is the normal variable which is assigned with the value 2, and you can use the constant again in the later part of the program without modifying it. Area equal to pi into r double star 2, which is pi r square, and then print the area of the circle, since pi r square is the formula for finding the area of the circle. So here pi is the constant, that is why it is represented as capital letters, and which means that the value of this constant should not be changed throughout the program. And if you observe the output, the circle area is 12.56 because we have assigned pi equal to 3.14 and r is 2. That means instead of typing the value which is a constant 3.14 wherever is required in the program, you can define it as a constant, and you can use that constant name which is a pi wherever you need it. The next one is Python literals, and literals are used to assign values to variables or constants. For example, you consider a statement L1 equal to 23. So L1 here is called as the variable name and 23 is called as a literal. So literals are basically they are used for assigning the values to the variables or constants. They can be numbers, characters or strings. L1 equal to 23 and L2 equal to 98.4 both are called as numeric literals because here we are using the numerical values for assigning the variables L1 and L2. Similarly, you can also have string literals where the string values are assigned to the literals. L3 equal to hello. If it is a string literal, it has to be enclosed in single quotes or double quotes or triple quotes is also valid. Then we have Boolean literals where the values can be either true or false with T and F as capital letters enclosed in double quotes. Then there is a special literal called as none. L6 we are assigning it as none, and then we are printing the values of L1, L2, L3, L4, L5 and L6. L1, L2 are the numeric literals. L3 and L4 both are string literals. L5 is a Boolean literal and L6 is a special value which is called as none. Now let us observe the demonstration of whatever the concepts that are being covered so far. Let us move to the Google Colab. So here we are using x and y as the names of the variables which are assigned with the values 20 and 30, and we are printing the values of x and y. So let us execute that. So here you can see the value of x is being printed as 20 and y is being printed as 30. And now let us see by printing the IDs of the variables x and y. Here you can observe x is assigned with 20, y is assigned with 30. So these two are distinct values. That is why two different memory locations will be allocated for x and y. That is why if we try to print the IDs of x and y, both the memory locations are different. On the other hand, if you assign the same values, to x and y, in this case you can observe x is assigned with 20 and y is also assigned with 20. In such a case, if you try to print the ID of X and ID of Y, which is nothing but the identifiers of X and Y, means which are the memory locations of X and Y, both are same. That means when the values are same, no extra memory location will be allocated to the variables. Instead, the same memory location will be shared by both X and Y. Now let us see, the Python variables need not be defined explicitly. That is why, depending on the type of data that you are assigning to the variable, we are going to have the corresponding type for the variable. Here, student name is assigned with a string type, age is an integer, gender is again a string, CGPA is a floating point, C1 is complex type. So if you try to print the type of the data, you can observe student underscore name is a string class, age is an int class, gender is again a string class, CGPA is a float class, and C1 is a complex class. So out of these, int, float, and complex are the numeric data types. And of course, we have another data type called as str. So basically, you need to understand that all these data types are classes and the variables of these type are the objects of the class. That means variable of type int is an object of int class. Here you can observe different types of assignment statements. X equal to 30 is assigning a single value to a single variable. Here A equal to B equal to C equal to 50. Here it is an assignment statement that shows assigning single value to multiple variables. Then another assignment statement, P comma Q comma R equal to 10 comma 20 comma 30 means assigning multiple values to multiple variables. So let us execute it and see the output for the variables. X is 30, A, B and C, all three are assigned with the value 50. P is assigned with 10, Q is assigned with 20 and R is assigned with 30. Next we have Python constants where we are initializing or we are assigning the constant value which is 3.14 to pi. The constant is being represented with all capital letters in order to indicate that this is a constant variable which should not be changed throughout the execution of the program. So if you print the area of the circle, you can observe that the value pi r square is being computed and displayed here. Next we have Python literals where we are able to assign different types of values to the variables. L1 and L2 are assigned with the numerical literals which are 23 and 98.4. So 23 is a literal here, 98.4 is a literal here. Similarly, the string literals hello and s are assigned to the variables L3 and L4, and true is a boolean value. Let me do this. Because true you need not enclose in double quotes because it is a boolean value. It is a boolean value, you need not enclose in double quotes. If you enclose in double quotes, it will become a string value. So L5 equal to true, which is a boolean literal, and L6 is none. None is a special literal which does not assign any value to L6. So if you try to print the values of these variables, you can observe L1 is assigned with 23, L2 is assigned with 98.4, L3 and L4 are assigned with hello and s respectively, and L5 is true. Remember, whenever you assign the boolean literal to any variable, true should be written with T capital and false has to be written with F as capital letter. L6 is assigned with none value. So this completes the demo of this lecture 1 of module 3. So with this, we came to the end of this session, and thanks for listening, and we'll meet again in the next lecture.